Now I would want to call upon Bala. So Balasundaram is basically from Cognizant. He works as an associate director. It is time to know how we can do testing, customization, and framework related operations with Terratest. A very warm welcome to you, Bala.
Thank you. Are you able to see my screen?
Yes.
Yes.
Okay. Hello all. Good afternoon, everyone. Today's topic is all about IAC, automation testing, customization, and framework with the Terratest. Here we see what is infra as a code, how we test IAC templates, how we validate the infra configurations, and what are the challenges we will face during the deployment of infrastructure, and what are the different type of validations we will focus. Introduce about me, myself Balasundaram, Associate Director in Cognizant Technology, playing a role of Senior Architect, leads cloud capability, microservices, and test automation capability for various customers. So here we have the agenda of today's session. First, we focus on what is the industry trends on cloud and what is the role of infra as a code, and a glimpse of how the IAC templates will be available. What are the general problem statements generally we will have while deploying the infrastructure on the cloud, and what is our automation approach and solution, and the unique solution we developed for IAC, the framework architecture, and apart from that, a key element of auto heal and consistency kind of solution we have within our framework. Finally, we see the benefits. Okay, here is the industry view of what analysts says about cloud. In 2020, global IT spending is projected to reach 5 trillion, marking a significant 9% increase. Another report highlights there is around 13% growth of SaaS-based products migrated from on-prem to cloud. Another prediction also says like there is an increase of 29% rise in infra as a code solution on the cloud. So analyst predicts, and these trends, that there is an impact of cloud technology in modernizing the business operation, digitalizing the platform, and adapting the new technologies. So here are some of the popular IAC tools evolved in market. Infra provisioning tools like Terraform, cloud migration, cloud formation from AWS, Azure resources, resource manager, etc. Configuring tools like Ansible, Chef, and Puppet, etc. Next, we see on infra as a code. Before we deep dive on the technical aspects, let's take a quick explore of what is cloud assurance, cloud infrastructure, and its ecosystem. When a developer commits the code, it needs to be deployed on multiple environments like development, staging, and production. In the past, we set up the infrastructure manually, and because of that issue, because of manual setup, there are a lot of challenges we will face. But using cloud, we deploy and manage the virtual resources on demand. In cloud ecosystem, that includes virtual machine, database, containers, serverless functions, etc. And this supports scalable and cost-effective solutions. So IAC plays an important role in cloud with respect to infrastructure provisioning on cloud. Next, we see the manifesto of IAC at a glance. Here we have use case to provision the virtual machine. Okay, the templates owned by the syntax and standard. So IAC templates has its own syntax and standards. So IAC template is in the form of JSON format, a key value pair. Here we have a sample IAC templates that are available for AWS, Terraform, Azure Resource Manager, GCP, and Plate. Okay. So for example, here we have in left hand side under AWS Cloud Formation, we have type. The type means the instance of virtual machine. So we will update our properties and characteristic of our resources like virtual machine, server, like that. We will update that one in our IAC template. Once this IAC template got deployed on the cloud, it automatically the infrastructure got created. Therefore, there are many challenges we will have because of frequent change in the infrastructure requirements. Because of that, these IAC templates need to be edited, need to be updated frequently based on the requirement change. Once any change or any update happened on IAC template, then we need to do a unit testing before we deploy on the cloud. So next, we will see what are different problems we will have. The first problem here we have is inconsistent infrastructure and deployment infra environment that can be a major pain point. That means the infrastructure and the environment will be inconsistent between development stage, development environment, production environment, and staging environment. In the past, we deploy the infrastructure manually. Because of that, there is a lot of issues, a lot of defects we found. To replace that one, cloud comes up with the IAC automated template, then it automatically deploys the infrastructure on the cloud. And the next problem statement here we have is lack of early defect detection in issue. For example, since we identify the defects in the past at the latest cycle of the testing, the cost of the defects will be higher. That is also another problem usually we have when we do the manual infrastructure setup. And there is a special skill need to be there to develop a IAC template and need to be deployed. Because of that also we have a problem within our QA. And there is a need of automation QA process also in place. The manual infrastructure testing is very slow and error prone because of manually creating the servers, manually creating the networks, manually creating the database. During that time, we will found lot of difficulties, lot of challenges in the error. So that is also one of the key problem statement. Another one is CI/CD pipeline is also not there in the current manual process. So these are the challenges underscore the importance of structured automated approach to IAC testing that what we will explore in next. So the automation approach, we will see how we will handle these challenges during the deployment of infrastructure. As we explore the role of automation and testing in infrastructure as a code, let's consider why these elements are crucial. The the automation ensures consistency across the environments. By automating the infrastructure setup, we ensure the standardized configuration across the development, testing, and production to minimize the risk of configuration drift. For example, once we automate the setup process, once we deploy the setup across different environment like production, staging, and development, what we will have, the standards of deployment, it will be there. There will be less defects will be there. That is the another approach. And after that, faster development cycle. Since we in traditional approach we follow the manual steps, but in automated way we enable the CI/CD process and other things and all for the rapid testing and iteration. And next one is early defect detection. Okay, while we deploy the infrastructure on the cloud, what will happen automatically? We will do a static testing. We identify the defects early using Terratest kind of tools, so that uh, the cost will be very less if we find the defects in earlier cycle. And because of the cloud adoption, the continuous testing and CI/CD pipeline is also be integrated with infrastructure provisioning. That also helps to reduce the downtime. Finally, we can have the security and compliance can be also automated along with the deployment process. Next, here we have the solution architecture. For example, once the developer uses the Terraform to configure the infrastructure, defining the cloud resources like virtual machine, network, storage across various platforms consistently, once the developer coded the Terraform code and he will deploy the infra as a code, IAC code, and to deploy the IAC code, they need to before they need to do the static testing. For example, the static testing will verify whether IAC code templates are created as per the requirements or not. For example, there are a lot of situations in real time when we do the infrastructure provisioning, we will see there is a mismatch in IP address, there is a mismatch in the name of the resource. For example, if I want to create a database with 2 GB or 20 GB, then automatically I will update my resource in IAC template with 10 GB like that. So it is not matched with the requirement. Similar kind of thing we will face in the network also. So before we deploy our IAC template, we need to do a static testing of IAC template before it got deployed. If any defects find in a static testing itself, the defects fixed in early cycle, and there is a early direction of defects is also there. Once the static testing is completed, then we will deploy our IAC code. Then after it got deployed, then our Terratest automation framework, what we have developed, comes into place, and it will validate the infrastructure, whatever we have deployed is correctly stood up as per the requirement or not, and it got integrated in a CI/CD pipeline. This is how generally we will have our automation framework that helps to validate the infrastructure is created or not. Okay, next we will see the automation framework what we have. We have developed a Terratest automation framework, and the framework that supports static testing. Like once the IAC template got created, the static testing on IAC template will be there. We have a set of library available. We have created these libraries will help us to validate the static testing of IAC template. And after it got deployed, then we will do a component testing, and then we will do a configuration whether the integration between the hardwares in the integration between two resources will be validated through configuration library, and we will validate whether the policy and standards followed. That means the naming standards of each resource while we creating. So those things and all we will validate using the policy validation. And the utility library the utility and data library that contains data driven. For example, we need to stood up our infrastructure across multiple locations like dev, staging, and production. And because using the data driven approach, you will configure the data mapping in the data driven library, and based on the situation it will validate in a pipeline mode based on the environment, whatever the input we are giving here. Finally, the reporting library, what we have, it will automatically sends to the stakeholders at the end of the execution. This is what the unique framework using Terratest that helps us to validate the infrastructure after it got deployed. So in general, in this framework, we have developed with enabled with auto heal feature. For example, we have set of jobs available in Jenkins pipeline. The first job, it will be run the Terraform test to stood up the environment, stood up the infrastructure on different environment. After it got stood up, automatically we will validate the next job in the pipeline will validate whether infrastructure was created as per the requirement or not. And if it is not created, automatically the Terratest code will send a mail communicator to stakeholders, and it will delete the infrastructure on the particular environment, and it automatically creates, based on the requirement, it automatically creates the right infrastructure with right requirements as per the customer needs. So these auto heal feature is also enabled while creating the infrastructure on the ground, on the pipeline. So here are some of the key benefits what we have with respect to Terratest we have. So in one of the implementation with the customer, the 40% of defects are identified early, and on the configuration issues. Mainly we will see the configuration issues in the uh, environment setup. So this framework identifies the effort and identify the defects earlier in the cycle. Similarly, the static testing of Terratest ensures 99% of the configuration issues early, and it will validate the security and policy kind of validation standards. It will verify during the static testing. And finally, so it identifies 25% of release issues earlier in the cycle. Any question on this?